Uh, let's check question 2 from the exam, grade 12, paper 2, or you can say chemistry. 2.1, study the organic compound below. So we are given the condensed structural formula, yeah? So to make life easy, since we are given the condensed structural formula, let's try and write the structural formula showing all the bonds. We also give the UPAC name of this structural formula first. So it means that we start here 2.1. We must draw the structural formula of this condensed structural formula. So let's check. The first carbon atom is having 3 hydrogen atoms. So this one is the first carbon atom having 3 hydrogen atoms. And then there is another carbon atom. This is the carbon atom. And then there is OO. So check, there is OO in the middle of the structure. So this one is going to give us a star. So we're going to have double bond O, and then O, another bond. Then this carbon atom with 3 hydrogen atoms. So this is the structure now. So that means this is the structural formula for this condensed structural formula. So now we can check. There is a functional group here. It is in the middle of the structure. So this is a star. So we can see now the homologous series of this one. We can write homologous series. It belongs to a star. And then let's check now. Let's give it a name, the UPAC name. So check this side. 1, 2. This is an acid. Then 1. This is an alcohol. So it means that we're going to start this side. This is 1 carbon atom. So 1 carbon atom is meth, but since this is ester, we name alcohols like we're naming a branch. So this one's going to be methyl. We name it like we're naming a branch. And then how many carbon atoms this side? 1, 2. So it's going to be methyl ethanoate. So the UPAC name of the structure is this one. The homologous series is this one. So now we can check now the name or the UPAC name of the alcohol that was used to produce this one. So since we named the alcohol like we're naming a branch, that means this is our alcohol. So the name of the alcohol is methanol. We take it from here, methyl become methanol. So this is the name of the alcohol that is used. So now let's check the questions now. 2.1.1, they said write down the UPAC name. So 2.1.1, the UPAC name of the structure already we wrote it. So we just copy and paste methyl ethanoate. We just copy and paste now. So that is 2 marks. So it means that they're going to get 1, 2 for 2 marks. So 2.1.2, the question said write down the structural formula for the functional group. So be careful, only the functional group. The focus is the functional group here. So this is the functional group. It means that now we're going to say C, double bond O, then O, and another C this side. So we can put C here. You can also show the bonds, is fine. So, but the focus is this part. So this is the structure for the functional group. So this is 1 mark according to the question. So 2.1.3, 2.1.3, the question said, write down the UPEC name of the alcohol used in the preparation of this compound. So already we wrote the name of the alcohol, or the UPEC name of the alcohol. We said this what is methanol. So we'll just copy and paste it now. Methanol. So 2.1.4. The question said, define the term functional isome. So functional isomer, these are organic molecules having the same molecular formula but different functional group. So we can say organic, these are organic compounds. Organic compounds having, can say having the same molecular formula but different functional group. Different functional group. So this is the definition. This is how we define the functional isome. These organic molecules, they have the same molecular formula. So when you count the number of carbon atoms and the number of hydrogen atoms and the number of oxygens, they are the same both sides. So that's why we say is that they have the same molecular formula but different functional group. So you'll see when we move on. So okay, now 2.1.5, they said write down the structural formula of this compound's functional isomer. So functional isomer, that means now we want to know the functional isomer of the ester, and the functional isomer of the ester is what is a carboxylic acid. So that means now we must move the functional group from this carbon atom to the last carbon atom. So let me shift this. It means that now we're going to move 2.1.5. We have 3 carbon atoms there, 1, 2, 3. So 1, 2, 3. And then we're shifting this. We are shifting the functional group from carbon atom number 2 to the last carbon atom. So we take this one and put it here, and then so now it becomes an acid. It was an ester before, now it becomes an acid. So this is our new structure now. So this is the functional isomer of the first structure. So remember, they have the same molecular formula. Let's check the first one. 1, 2, 3 carbon atoms. 1, 2, 3 carbon atoms. So this is C3. Let's check the number of hydrogens. This is 3 plus 3, which is 6. So this side is 6 hydrogen atoms. Let's check this side. 3, 4, 5, 6. So this is H6. And then let's check. We have 2 oxygens this side, even this side 1, 2. So we have O2. So this is the molecular formula of this compound. So that's why we're saying they have the same molecular formula but a different functional group. I hope it makes sense. So now question 2.2. 2.2, they said the UPEC name of the organic compound is. So since now we are given this UPEC name, 2,4-dimethyl hexane 3,1. So now you must check the UPEC name is 2,4-dimethyl hexane 3,1 or on. That's up to you. So Now let's check. You check the ending of the name. The ending must tell you the homologous series. So according to this ending, the homologous series of this one is what? Is a ketone. You check the ending. ONE. ONE. So the homologous series is a ketone. So before we answer the questions, we must check now, we must draw the structural formula before they ask us. So we must draw the structural formula. How many carbon atoms? This one, heads. That means 6 carbon atoms. So this 1, 2, 3, 4, 5, 6. And then let's check. In carbon atom number 3, there is a functional group which is a ketone. So 1, 2, 3. Let's take this one. So carbon atom number 2, there is a methyl as a branch. So carbon atom number 2, we have methyl. And also in carbon atom number 4, we have methyl. So 1, 2, or 1, 2, 3, 4. So even here we're going to have a methyl. So we just place all the hydrogen atoms. Make sure that you show all the bonds and all the hydrogen atoms. Also make sure that the carbon atom has 4 bonds, or around each carbon atom there are 4 bonds. So now this is the structural formula for the UPEG name here. Now, we also said the homologous series is a ketone. So now what is the name of the functional group here? So the name of the functional group is a carbonyl, right? So this one is a carbonyl group. We can say carbonyl group. So now let's go to the questions now. 2.2.1. The question said, for this compound, write down the homologous series to which it belongs. So the homologous series already we said is a ketone. So we just write a ketone here. This is the homologous series. Life is easy, right? So now 2.2.2, they said we must write down the structural formula. So this is our structural formula now. We just copy and paste. So now we're copying. We just copy and paste. We simplify life. Carbon atom number 3, carbon atom number 2 is hydrogen. Carbon atom number 4. Life is easy now. So this is the structural formula. Life is easy. So let's check now. 2.2.3, you write down the the structural formula of its positional isomer. So here we have the positional isomer. They are not talking about the functional isomer. So positional isomer is different from the functional isomer. So let's open a new page. Now let's check. 2.2.3. First, let's draw the structure of that one, or the one that we took out. This one, we must draw this one first. So we said we have 6 carbon atoms. 1, 2, 3, 4, 5, 6. So we said carbon atom number 3, there is a ketone there. So a positional isomer, we don't shift the functional group here. The only focus is the substituent. Carbon atom number 2, there is a methyl. Also in carbon atom number 4, there is a methyl. So um, the only focus here is the substituent. Let's leave the functional group alone because they're talking about the positional isome. So check, we have a branch here, we have a branch here. So what we must do, we just change the position of the branch. So this one is in carbon atom number 2. We can shift it from carbon atom number 2 to carbon atom number 4. That becomes a positional isome. So now the positional isome of this structure now is going to be this way. Still same molecular formula. They have the same molecular formula. 1, 2, 3, 4, 5, 6. So here now we shift the branch here. We're shifting this branch. We're shifting this one. We want to put it here. So carbon atom number 3 still we have a ketone. Then carbon atom number 4, we're going to have a branch. And then let's say also in carbon atom number, let's put it here. So let's check now. I've shifted this one. Okay. Let's fix the mistake. Let's say here it's hydrogen. Okay, let's cancel this one. Let's start afresh. This one, I want to fix something. 1, 2, 3, 4, 5, 6. So carbon atom number 3, there is a ketone, and then carbon atom number 4, there is a branch also in carbon atom number 4. Let's put it in carbon atom number 4 to make life easy. Okay, so let's check this one first. This one, it was in carbon atom number 2, right? Now we've shifted the branch from carbon atom number 2 to carbon atom number 4. That means now it's going to change the UPEG name. The UPEG name now is going to be 4,4. The UPEG name of the positional isomer is going to be 4,4 dash then dimethyl, something like that. So the positional isomer, we leave the functional group alone here. We are not focusing on the functional group because this is not a functional isomer, it's a positional isome. So we just change the position from first carbon atom or from second carbon atom to the third carbon atom or the fourth carbon atom. You change the position of the substituent. I hope it makes sense. So now question 3 or 2.3, sorry. 2.3, okay, just like that. 2.3, it says study the following chemical reaction. So on the chemical reaction here, we are having this balanced equation. So the balanced equation here is 2C4H10, let's leave the gas alone, plus 13O2, and then it gives us 8CO2 plus 10H2O. So here, this is what's happening. We are reacting butane, remember, C4, 4 carbon atoms, 10 hydrogen atoms. So this is butane reacting with oxygen gas. So the product is carbon dioxide plus water. That is before we balance the equation, right? So this process or this reaction, we call it a combustion. So this is the combustion reaction. We react a compound with oxygen gas. The product always is carbon dioxide plus water. So on the combustion reaction, the product is carbon dioxide plus water. So we react a compound. It can be butane, can be methane, it can be propane. We react it with oxygen as always. So sometimes they'll tell you that this is butane benzene air. Write down the balanced equation. So you take butane, you add oxygen gas, Then the product is going to be carbon dioxide plus water. Then after that, you balance the equation. So the equation originally, it was C4H10 plus O2 give us CO2 plus H2O. This was the first equation before they balance it. So now let's read the question. They said 2.3.1, name the type of reaction represented above. So already I have said something that this is combustion. This is a combustion reaction. So you must tell them that. Then 2.3.2, they said write down the UPEC name of the gas that reacted with oxygen in the reaction above. So this is the gas, this is C4H10. So C4, this is bute. So this is a butane. When you check, in butane we have 4 carbon atoms and 10 nitrogen atoms. So this one is a butane. So here we are having a butane reacting with oxygen. So they wanted to know the UPEC name of the gas. So that is butane according to the reaction.